Alright, this is Mr. Benner, and I'm going to go over how to do this problem 13.13 on mastering. And full disclosure here, I started working on this thing and realized that I could, I, the approach that I was taking the first go around wouldn't make a whole lot of sense because I thought I needed to do something, and then I realized I did not need to do something. And I'll at least talk you through that. So what we're imagining that we have going on here is we have a submarine down underwater, and it's got some kind of portal on the side of it that apparently is made out of glass, and that submarine is somewhere down in the ocean, and the density of ocean water is rho ocean is 1030 kilograms per meter cubed. Now, for conceptualizing this problem, at first I thought I was going to have to account for the atmospheric pressure inside the submarine pushing out and the pressure of the water pushing in. However, after thinking about that some more, what I realized is that the pressure up here at the surface of the ocean was going to be atmospheric pressure, and the pressure inside of the sub is also atmospheric pressure. And so what that means is that we just don't have to worry about the pressure inside of the submarine. All we really have to worry about is just how deep underwater the submarine can go. We'll call that H underwater. So what I did is I went through, and this part was fine, like what I did before was fine. I just figured out how much pressure can that window withstand, and I just took the force that they gave me, the 1.1 times 10 to the 6 newtons, and I divided it by the area of the glass. So it's a circular piece of glass. And the way you calculate the area of a circle is pi r squared. So they told me a 30 centimeter diameter. I divided that diameter by 2 to get 15 centimeters or 0.15 meters. And your pressure units do need to be in pascals for this. So you need to do newtons for force and meters for area, or for radius, and then find the area there. So anyways, I did all that, and I got approximately 15,560,000 pascals. It would be better on your calculator to just carry all those digits and not lose anything. But anyways, so I got that, and the way that you calculate pressure due to depth in a fluid is you calculate gauge pressure based on the height. So what we're saying is here is like, hey, we can go up to a maximum of 15,560 pascals. And the question is, what height or what depth of fluid can we go in the ocean here? So what we're going to do is rearrange this equation to solve for H. So you divide both sides by rho g, and you would get H equals our gauge pressure divided by rho g. And that pressure is this quantity over here, the 15,560,000. And we're going to divide that by the density of seawater, 1030 kilograms per meter cubed. Times G. And mastering likes 9.8, but on the AP exam you can use 10. All right, and when you do that, you're going to get a maximum depth of 1,540 meters or so. And that does check out with the answer key. So there you go. Hope that helps.